Welcome to the Advent of Code. Today we'll look at the puzzle of day 3. It's called Crosswise. And the task is, let's see, the wise twist and turn. Okay, you need to find the intersection point closest to the central port. So I guess okay, specifically two wires are connected to the central port and extend outward on a grid. Okay, so we have a grid, we have a wire. And the wise path is described by this. Yeah, right 8, up 5, left 5, down 3. Okay. And okay, we got these intersection points. And what do we have to do? We return the one that's close to the central port. Okay, we are Manhattan distance. Okay, great. So if we have like these, this will not be returned because this is closer because of 1, 2, 3, 1, 2, 3, it's 6 away. Okay. Yeah. As you can see here. Okay. Now, there would be like two approaches, I guess. So either we use like the simplest thing would be to use like a two-dimensional array to mark, to basically generate these maps in memory and then just do collision detection if you have like two maps and you put them onto each other, and you can check where the things collide and like find the minimum or find the coordinates with minimum Manhattan distance. But they don't actually specify here if it like what is the range and if it actually can go like into negative space. So I would just use a map for that, or a map set. Let's see. Let's just start. We have to fetch them, but so let's pour the input in here. Great. So input is there. Perfect. And we have to create our file. So just the standard stuff. We have to read the wire lines. For step in input split, we have to do that 2 times. Now we have to map these wires to one of these. So I'll just call it map wire, and we take a wire. I'll just define a map. So we go through each step in the wire, and we know that the first character is always the direction. So I just call this D, so just to encode the direction. So if we go right, we go 1 to the right and 0 up. If we go left, we go -1 to the right and 0 up. If we go down, or no, up, we go 0 and 1. And if we go down, we go 0 and -1. Okay, great. And the distance we have to walk is actually in the substring d1. Okay. For in range int d, step 1. And we need to know which direction. So the x and dy should be dy step 0. Okay, and then we have to know our x and y. We start at 0, 0. If we now have that x and y, we can just x, y is equal to x plus dx, x, y plus dy. And we also have to be careful that we set the values. So if x is in M, we can just, okay, let's see. So if x is in M, we can actually just do m x at y, else we just do like mx is equal to set of y. Yeah, I think that should work. Then in the end we can return our m. So let's just try that for map wire, wire1. We just feed it some input from here, so we can just test it. Very some basic stuff. This looks basic. Let's see. Just make it executable. So 1 0 2 0 3. So I think that looks fine, I guess. So we walk A to the right. Yeah, that works. 1 2 3 4 5 6 7 8, and then we walk at the 8. We walk up. Yeah, it looks good. Perfect. So we do that for both wires. And now we can check the intersection between map 1 and map 2. I guess we could that. Let's do it in a function. So we can do for x in map 1, for y in map 1x. If x in map 2 and y in map 2x. And now we also have to keep track of these Manhattan distance things. So MD, I just call it MD. I think that works. So we have a collision point, and MD is equal to the minimum of MD and absolute x dot absolute y. Okay, I think that should work. Min Manhattan. Wait, let's call it min Manhattan. Min Manhattan of map 1 and map 2. And let's feed it some stuff here. So this should return 6, I guess. None. This is not good. Never mind. Let's try it again. Yeah, 6. Okay, let's try it with some of these inputs. 159 looks good. Looks good as well. Okay, let's try it on the input. 446. Great, nice. 1 gold star. Next. Okay. You actually need to minimize the signal delay. To do this, calculate the number of steps each vector. Okay. So I have to return this intersection point instead of this, because like if we walk up here and down there, they have taken in common, like, okay, the common number of steps is like lower than in that cross point. Okay. I think we can do that in the same file actually. Let's call it. We have to do some optimizations, or like some changes in the map wire thing. I think we also have to keep track of the number of steps we have done in our wire. So instead of this, we should do mxy equals c, and c is equal to c plus 1. And here we just do y, map y to c. Okay, and let's call it MC. For x in map 1, for y in map 1x, and if they collide. So now we have to check an MC, I guess, is equal to min MC and map 1 xy plus map 2 xy, because we have to like sum up the number of steps they take in common. Let's just do min steps map 1 map 2. Okay, I think that should work. Let's try it on some well-defined input. 610, yeah. Okay, and the second one. 410, perfect. I think it works. So let's just feed it input 9006. Great. 1 gold star. We completed day 3.